And welcome back, guys. This is Chris here with another tutorial on manufacturing process part 3. In this tutorial, it's going to be a short one. Right, we will be learning how to draft and how to identify drafts, right? So, and the two different types of drafts as well. So let's get started with identification of drafts. So what you see here in front of you is a positive draft. Green means positive draft as indicated by the legend here. So the positive draft is more than the amount you have equipped here, inputted here, which is 0.5. And the reason why it's 0.5 is because according to the cardinal rules of injection molding, it says that you should have a 0.5 to 1.5 degree for ejection, right? And this is only for smooth surface. If you have any textured surface, it would have a different degree, possibly 3, possibly 5, possibly 10, right? And always we just put a minimal so that when we input in, we can find out the issues that are less than the amount we inputted, right? So the reason why these are all yellow is because of requirements and specification by our lecturer, as these are all caster wheels and hydraulic pistons, which already has a certain diameter, and they do not want them to be angled at all. So other than special circumstances like this, all of your injection molded parts should be angled and towards A and B part so that it can be ejected out easily. So here is your A and B part, A and B part, and that is why you can see there's two different green sides over here. They are A, this is B, A, B. A is upwards, B is downwards, right? So let's get on to our part here, tutorial, right? So this is your model that you have made previously, and now we will be drafting. Learning how to draft analysis first. It is under evaluation, under tabs. If you can find it, it's under tabs, evaluate here, enable it, and you have under draft analysis. Draft analysis, you would want to put on any perpendicular flat surface that is perpendicular to the angle you want to check. In this case, we're just going to use a top plane because it's much more reliable than any flat surface, right? Then you can see the arrow pointing outwards, so this would be your A part that's going to be pulling outwards, right? And then this is going to be a B part that's pulling downwards, right? So you need angle all the way here as well, and for here as well, right? So all this needs to be green, which we need so much angles down here, and similarly from down here as well, right? So let's get started with angling. So now let's just press OK, and you can still have it. You can always uncheck it when you don't want. And under features, draft, it's draft here. So we have two different types of drafts: neutral plane drafts and parting line drafts. Neutral plane drafts at the plane that you have selected, because drafting only works in plane. So so drafting, you do not want to have any curved surfaces like this, right? So you want to move back to a point where there is no fillet, because fillet causes the draft to not work, because most of the time drafting works only on the plane itself and not the entire body. So what I mean is, if it drafts, it's going to draft this side only, right? It's not going to draft all the way here and here. So if you have any curved surfaces, right, you won't be able to draft this because it doesn't work, right? So okay, so let's start with drafting. We talk about the simpler one of the two, which is neutral plane draft. Neutral plane drafts work by having the plane. So if you were to click on this plane, your draft would start on this side. So whatever's above, right, it will draft upwards, right? It will draft in or draft out, right? So you can choose whether you want to draft out or draft in. So this is drafting outwards. So, and since our mold is going to be pulled outwards, we want it to draft inwards, right? Inwards. So A part is going to be draft inwards up here, and so that you can see it goes in. Click OK. You can see it becomes green, right? If you were to do it wrongly, right, it will become red like this, right? And you will know, oh, why is it not all green? It's red instead. It's a negative draft. Oh, you need to change your draft. This is why draft analysis is important, right? So you made this. However, the issue is that neutral plane drafts, right, they start drafting on that plane. So if you were to put a draft face here and here and here, right, you'll be able to see that this is draft outwards, right? You see that it doesn't start down here. It drafts the entire thing. Even if it cuts in here, you can see it cuts in, yes, correct. However, the bottom side, it also cuts in a bit. So this is why is this bad? This is bad because once it cuts in like that, right, it chips off maybe a few millimeters off of your dimensions, right? And that is not the specifications required by your client or the lecturer. So you need to, in this case, right, you need to use a parting draft, because parting draft, it starts the draft at the parting line, right? So at the parting line, direction of pull would be where it's gonna, pull the draft inwards, right, which is perpendicular, always use. And then your parting line would be where it's gonna draft, right, where it's gonna start drafting. Unlike neutral plane, where it starts drafting where the plane is, this one start drafting on the edge of the line. So you want to click on all of this line so that it drafts inwards, and you can see that down here there is no draft at all, right? There's no draft at all. This is important. Remember, right? And that's how you differentiate them. You can see here, draft outwards, inwards, and no draft, right? So it does not change your dimension. Very important. This is fine down here because it starts down here and your draft inwards starts here anyway, so it is fine then. And you get this, right? So you click on your line and you click on a face. Your face is always the face you want to draft, right? Your direction of pull, right? So your direction pull is not down here, it's up here, right? And then you get this, ta-da, green. And then once you roll back, you will see, oh, there we go, all green, very nice. However, now we're missing its downside here. Let me just fix this very quickly. It's this part, this and this, because this has been drafted, so it's gonna change a little bit. Vertical, and there we go. So now we have drafted the top part green, very good. And hopefully you had too. We will draft the bottom side as well. Same thing. All right, same thing. Try it out. Draft, direction of pull. Direction pull, we will be pulling it here, right? Because we do not want to draft this side outwards because it's pulling downwards, right? The mode is going to come from inside to out. So if this one is angled outside, it will have an overhang and it just doesn't work, right? So you want to pull this side, right? This side, this line here, and this line. So it should be the inside line. Should give it an angle. Show preview, other face, there we go. Other face, and there we go. So here is your, okay, so I am back. So I finally got it to work, right? So we have drafted here. So same thing lah, same thing. I just don't know why it didn't work just now. I have made a face on this side, so it will draft towards this direction, and the lines are, these lines are lines here and line here, and they have drafted in. Same for this side as well, they have drafted inwards. And so to create this this very nice draft angle here. However, as you can see, the issue here is that you see it cuts off. It becomes more and more thin, more and more thin. This is why they say in the cardinal rules, it says it should only be 2.5 to 3 times the nominal wall thickness, right? There's a reason for that lah. Yes. So how can we solve this issue? Well, we can solve this issue coming back to before we model this, and then we need, and before they draft that surface, let's do our check of draft analysis first. Draft analysis check, top view. This is lacking, we need to draft that side as well. Okay, let's complete this draft first. Sketch, draft analysis, draft. Same thing, this time we use neutral plane, face. Right, drafts. Now let's use parting line, because we do not change the dimension, right? Or should we? Because the thickness, yeah, I'm afraid of the thickness will go too much. Then let's go with this then. parting line instead, right? Bam. So you have this, and then your draft angle should not have any issue. Draft, evaluate, draft, click on top part, turn around, okay, get the draft. There we go, we got the draft. All right, so back to this issue. We have yeah, this one. This is the angle. This is too thin to the point that any angle would cut it off, right? So we need a certain amount of only a certain amount of depth to it, right? So we can't have it that much. How should we get it to be that way? So let's go back to when we made this. Yes, so when we made this, we wanted to cut this out. Alright, so we need to remove this as merge, so that we can cut this more so inward. Right, we will cut this, slice this in half, section view it. Right, let's close up the evaluation. So now we want to slice it a bit more inwards. Right, so this is why draft angle is important. You can draft analysis, so that you can actually draft and you can tell and you can solve issue. That's how we work in Solidworks anyways. So all of this is removed. Hello, doesn't want to remove. Oops, noisy. So this is that. Okay, so we want it to be roughly you don't have to follow it completely lah. We don't have to follow the rule completely, because we're only making a chair base and it's not really required to be 2 to 3 times. You can just put something like 30, but it shouldn't be too thick lah. Shouldn't be too thick. If there's any issue later, we'll have to see, because I'm afraid that if it's too short, right, it won't have any structure or integrity. So this cut, keep putting. So this cut does not work. Do you know that you should be cutting this instead? Not this, but this thing instead. Extrude thin, and there's no issue. Alright. Why is this an issue? So each time you change something, you need to solve, and here we will be solving for it's these things. Oh no. Right here and here. Just very rough and clean look. So it's gonna be thinner on the inside, right? And so here it has issues as well. Does not really trust. Just make it a corduroy, and it doesn't want to cut this, so you want it to cut this instead. All bodies, right? And then you want to combine all of them. If I combine, and add, right? And then you can draft, right? And this time I'm going back to draft. Doesn't want to draft now. Should be fine after we click these 2 points. Who doesn't want to draft? That's a bit awkward. It's okay, we can always. Does this work though? This and this is okay, right? Yeah, this and this is okay. So let's draft it on a different way. Draft this side. I really do not want to make this thick, but I don't think there's a choice here, so I think it's better to just draft it outwards, right? What is that, this issue? What is that? Where did this come from? It seems like there's an issue here. Yeah, there is an issue there. I think it has to do with this. So I will have to solve this. Solve this as well. I'm moving to the side. Yeah, let's put something like 2. Why not? Then now there should be no issue with the drafting. Combine draft. Yep, there we go. So sometimes it's a bit finicky. You just have to work with it and solve the issues, right? So we have done our drafting for today. So let's do our one final drafting check. Draft analysis, top part here, and bottom side would be like this. And to ensure that we have no dimension change, we should always at the end of it check for your dimension. So here it's been yellow. Does it still have the same dimension? It's 1.5. Okay, so these ribs are still fine. Thickness is okay. Is this still 3.6 36 cm? Yes, it is. Okay, great. So we have completed all of this, and you have learned how to draft for today and created a draft analysis. So in the next tutorial, we'll be checking for thickness analysis and finally starting our FEA. Yep, with our local mesh refinement. And hopefully this one will be too short for an issue, but we'll have to see, right? So one final check before we go down here, up here, green. Perfect. This is what we want to see. This is called very nice. All right, there we go. So I'll solve all these issues and then I'll be back and see you guys in the next tutorial. Bye bye.